Hello students, after a successful landing of our Chandrayaan-3, I have got an opportunity to talk about the Chandrayaan-3 mission one more time, this time with the full description of the entire mission, its major objectives, its major stages, and what will happen now if the Chandrayaan-3 has already successfully landed, what is going to be the next stages, what is the function, what is going to be the output of the Chandrayaan-3 rover, Chandrayaan-3 lander, and we'll also see how India's space program is going to get progressed with this particular mission. We'll also be looking at how other countries are involved into their own significant lunar missions and what are their objectives. Although the objectives are more or less similar for even India or for any other countries. So let us start, guys. So as we all know that Chandrayaan-3 has been a part of the major Chandrayaan legacy. In 2008, India demonstrated its first Chandrayaan-1 mission. This mission was not supposed to land on the moon. It was supposed to only orbit around the moon. So it was an orbiter program which was supposed to only revolve around the moon surface. Although it had a small impactor that impacted on the lunar surface, and the Chandrayaan orbiter, it simply looked at the photograph and studied how this impact has created the disturbance on the moon surface. With this disturbance, we can easily predict what kind of elemental composition the moon surface might be having, what kind of responses the moon may give for any kind of meteorite or asteroid strikes whenever it happens on the moon surface. Then secondly, Chandrayaan-2. It took us almost 11 years, wait to launch Chandrayaan-2. Why? Because Chandrayaan-2 was not only an orbiter mission, guys. Along with being an orbiter mission, it was also equipped with a landing equipment. Plus, it also had a rover. But unfortunately, it was the lander and the rover that eventually got, disconnected from our ISRO's main base stations at Bangalore, and eventually it was this part that was declared to be a failure. Although, according to the official records, Chandrayaan-2 was still a 97% success because the orbiter was placed in the right orbit. It was performing all the required tasks. Only the lander and the rover, which was contributing somewhere around 3 to 5% of the mission, that particular part failed. Okay. In fact, Chandrayaan-2 failed somewhere when it was just 350 meters above the surface of the Earth, right? And you will notice that there happens to be a huge similarity between the Chandrayaan-2 payload and the Chandrayaan-3 payload. We'll be looking at it here. Chandrayaan-3, on the other hand, it has been our latest mission in the Chandrayaan legacy, and it was launched on, on 14th of July 2023, and it successfully landed on the moon on 23rd of August 2023. Right, so let us start our journey for Chandrayaan-3. This is a photograph of Chandrayaan-3. You can see this black color ramp. If you guys can notice this black color ramp on the surface, this ramp was the one where our Chandrayaan rover has been parked, and eventually it moved out from this ramp itself. Now, what is the objective of Chandrayaan-3? The objective of Chandrayaan-3 is still the same objective. We had to demonstrate safe and soft landing on the lunar surface. The idea of the soft landing, you can take inspiration from a helicopter, guys. You guys must have noticed how a helicopter lands. When a helicopter lands, it lands very slowly, very steadily, very slowly it will land without causing any kind of aberrations, any kind of damage to the internal payload. So that demonstration of a landing is known as a soft landing, right? So soft landing is something which is a primary condition when it comes to automatic landing equipments. It has to land on the surface under the circumstances of a very soft speed, very soft walking speed that Chandrayaan-3 has already demonstrated. To demonstrate rover roving onto the moon, so Chandrayaan-3 has already successfully demonstrated a rover to slide out from the lander, and eventually it has already started moving, making the first impressions of Indian emblem onto the lunar surface. Then its objective is to also conduct in situ scientific experiments. In situ means on-site scientific experiments. So the on-site scientific experiments, for the first time, as we have landed onto the moon surface, our Chandrayaan-3 rover and lander will perform on-site scientific experiments on the moon surface, right? And those experiments we'll be looking at in a short while. Now, when you look at the major components of the Chandrayaan-3 rover, I'm not considering the LVM-3 rocket that was used for launching this particular Chandrayaan-3, because it will eventually become a quite out of context topic. We can have a separate video just to talk about the various launch vehicles of ISRO. I have basically concentrated only on to the Chandrayaan-3 major components. So when you look at Chandrayaan-3, there are three major components that Chandrayaan-3 is made up of. One is basically the propulsion module. The propulsion module, as the name suggests, it is meant to propel the entire Chandrayaan-3 rover to the right destination, to the right orbit, from where it can start descending vertically downwards into the moon surface. So the propulsion module is basically meant to propel the Chandrayaan-3 into the right orbit, into the right altitude. Then we have got the lander module and the rover. The lander module is a fully automated module, guys. It is going to be working completely automatically. So it is a fully automated concept, and this fully automated lander is going to detach from the propulsion module, and then on a set day it is supposed to land. So this was already demonstrated on the 23rd. So it got detached from the propulsion module way before the 23rd of August 2023, and then it started its descent of almost 24 kilometers, on the last date of 23rd of August, right? And then inside the lander module itself, we have got the rover, which is supposed to take some on ground in situ experimentation, right? It is going to travel across the surface of moon, right, on the near the south pole surface of moon, and will conduct experiments. Now this is the actual photograph of the propulsion module and the landing module. So here you can see the propulsion module and as well also the landing module, right? You can see that the solar cells that has been used here compared to the Chandrayaan-2, they are much bigger in size. They are bigger in size just to make sure that there should not be any dearth, any lack of electricity for the electronic equipments to function. Even if the sensors that are going to function, they will be connected, they will be working most likely with electricity only. And all these electric equipments, they have been made bigger in size so that the electrical power supply SPV modules, solar photovoltaic cell modules, they have been made bigger in size so that they capture the sun's light and provide flawless continuous flow of electricity to the sensors so that the chance of failure can be minimized. All right, now this is the second part of the components. This is where we are seeing the entire landing module, and within the landing modules you can easily notice the ramp opening and the rover moving out. Now this rover, this is a simple pictorial diagram of the rover. It is a six-legged rover. You can see the 6 legs of Chandrayaan 3 rover here, and it is also equipped with a solar cell that will be functioning till the time there is sunlight received to this particular rover. Then when you look at the major payloads, Chandrayaan-3 contains total 6 payloads. There are total 6 payloads that are part of the Chandrayaan-3. The first payload is basically deployed, or it is basically attached with the propulsion module. With the propulsion module, we have got the first payload attached, and this payload is known as SHAPE. SHAPE stands for Spectropolarimetry of Habitable Planet Earth. Now you have to understand there are a lot of features. See, we have so far have not confirmed any planet in our universe. We have discovered a lot of planets, by the way, but we haven't been able to confirm even a single planet other than planet Earth to support life. Now just imagine if Earth is the only planet that supports life, then of course when you see the images of Earth from space, they would of course be sighting differently than any other planet, guys, and that is a very obvious sign of life. So SHAPE happens to be a spectropolarimetry of habitable planet Earth. It will start recording certain signatures. It will start recording certain, telltale signs which Earth reflects to the outer space. And by looking at these signs and comparing these signs with any other planet, we may be able to quantify how different our planet is from the rest of the universe. And by knowing these signs, it may become possible for us that tomorrow, if ever we discover a new planet that may show signs of life, we can compare the same signals with that of Earth and find out the possibilities of exploring that planet further in order to find some real living evidence or evidence of life. So this is basically the SHAPE module of the Chandrayaan 3. It is part of the propulsion module equipped in Chandrayaan-3. Now, when you look at the landing module of Chandrayaan-3 basically contains 3 payloads. The first one is Ramba LP. The Ramba LP is basically a payload that is meant to measure the surface plasma of Chandrayaan-3. Now, what do you understand by surface plasma here? Now, see, when you talk about plasma, guys, what is plasma? See, plasma by definition, plasma is known as high temperature ionized gases, or even if there is no ionized gas, even though there is no high temperature, ionized gases in general are also known as plasma. Now see, basically how this plasma is produced. The plasma is produced by a process known as photoionization. It is produced by a process known as photoionization. Now basically, let's try to break down this term so that all of us are able to understand it clearly. Now what exactly is an ion? You can see some keywords here. We can see the word photo here. We can see the word ion here. So let's try to break down the things here. What is the meaning of the word ion first? What is an ion, guys? An ion is nothing but charged atom. An ion is nothing but a charged atom, guys. Ion is nothing but a charged atom. So basically what happens whenever you look at any atom around you, आप कोई भी atom देखें अपने around, whenever you look at any atom around you, you will notice that every atom, like say for example, if I take hydrogen, hydrogen has one atomic number, so it has one proton, and around this proton it will have one electron, right? One proton, and around this we have one electron, right? Electron is negative, proton is positive. I hope you guys can understand, right? Electron is negative, proton is positive. Now between this negative and positive, there happens to be a strong force of attraction, guys. There happens to be a strong force of attraction, and this attraction is basically caused due to electromagnetic attraction, right? We have electromagnetic attraction between the electron and the proton, right? That's how the hydrogen maintains its integrity. Similarly, if I look at helium, helium is atomic number 2. So when you look at helium atomic number 2, it has 2 protons. It has 2 protons, and around the 2 protons, it has got 2 electrons, one electron here, another electron here, 2 electrons here, and between the 2 protons, both of them are positive. I'll put 2 positives here, and both these positives will be attracting 2 negatives, and it will be maintaining its own natural stable structure. Now what happens, guys? Just think about it. Now this attractive force that exists between electrons and protons, now this attractive force is known as electromagnetic force of attraction, right? It's an electromagnetic force of attraction. Now just imagine if I pick up this particular atom, and I place it in front of me in my hand. So we can see that at the center we have got the proton, and around the proton we have got electron. Electron is negative, proton is positive, and that's how all of them are attracted to each other. Now if I want to take this, or this atom, and I want to turn it into its ionic form. So ionic form are those where the atom is charged. So I have the atom in front of me. It is having a proton at the center and electron around the center, and I want to change this into its ionic form. इसको ionic form में change करना है, right? We have to change it in its ionic form. So how do you exactly change this entire substance into its ionic form? So what we'll do here, we'll try to apply a force, guys. We'll try to apply a force so that this electron, it gets dislodged. We'll try to apply a force here so that this electron gets dislodged out from its atom, leaving the proton alone. So if I can dislodge this electron, if I can throw this electron out from its atom, leaving the proton alone, then what will happen to the hydrogen atom, guys? Once the electron is lost, then the proton becomes imbalanced. There is a positive charge and it is imbalanced now. So what will happen now? The hydrogen will eventually turn into a H positive ion because it has lost the only electron that it had. It has turned into H positive ion. Are you guys able to understand? It has turned into its H positive ion once it loses this electron. So basically the idea is to turn an atom into its ionic form, and once an atom breaks into its ionic form, it basically gets a charge. So the idea of creating a plasma is known as photoionization. So what we are doing here, see, we all understand that there are a lot of high energy radiations from the sun that hits the moon surface, there are a lot of high energy radiations, and mind my words guys, sun has some really high energy radiations in the form of x-rays, in the form of gamma rays. There are a lot of radiations that the sun emits, and most of these radiation are reaching and hitting the moon on its surface. So imagine if I want to throw this electron out of the moon surface to turn this entire atom into its ionic form, I simply have to hit this electron with a high energy object, right? With a high energy force. And that force becomes the light of the sun, the high energy radiation, the high energy radiation that the sun produces. So we are going to take some high energy radiations and we'll throw those high energy radiations onto the electron of this particular hydrogen. And when we throw this high energy radiation onto this electron, the electron may absorb this energy, and then it may absorb this energy to a sufficient quantity so that this electromagnetic force of attraction, it becomes weak, and the electron eventually dislodge out of its entire atom. It will dislodge out of its entire atom. And once the electron is lost, guys, then what is left? The negative charge is gone, and what is left is the proton left alone, and the hydrogen will eventually get a positive charge. It has turned into its ionic form. I hope you guys are able to understand that how the ionization of gases or the ionization of matter may happen onto the lunar surface. If you haven't been able to understand this, please rewind this particular part and look at this one more time, and you can understand so how these high energy radiations of the sun can cause ionization of gases and matter on the lunar surface. And by studying the ionization patterns of the lunar surface, mind my words guys, we haven't been able to learn what exactly is happening on the lunar surface so far in all previous space lunar missions. No country in the world has actually come up with the answer to this question, that how exactly the solar radiations are affecting the chemical composition, the gases, the ionization of gases and such, right? So far there have been a lot of speculation. India's Ramba payload will be the first such equipment that will be helping us to find out the behavior of surface plasma, the creation of ions and electrons on the surface of the moon. For the first time, India may become a country to find out the answer to this question. Then next comes the CHAST, Chandra's surface thermophysical experiment. Now, like in the previous topic, I myself shared that moon is exposed to some high energy radiations, right? Now, because of that high energy radiations, the temperature of the moon also fluctuates, guys. You'll be surprised to know that if you consider the moon's surface, if one side of the moon is receiving sunlight, here the temperature can easily rise up to a positive 100 degrees Celsius temperature. Very high temperature can reach, right, up to a positive 100 degrees Celsius temperature. But where there is a shadow zone, here the temperature can fall up to minus 180 degrees Celsius temperature. So there is a massive change, massive shifting of temperature that we see on the lunar surface. It varies from, it can also, there could be also places where it can go up to positive 30 degrees Celsius. So 30 to 100 degrees Celsius the temperature on the bright side, and on the dark side it falls up to minus 180 degrees. So when there is such a massive difference of temperature, our Chandra's surface thermophysical experiment will try to find out how the thermal properties of lunar surface changes from the sunlight part to the darker part. So when it will see the transition, like how the surface property changes when it is exposed to sunlight, does it change the surface thermal properties at all? How much heat is being conducted into the lunar soil? How much heat is being trapped for a longer duration? And that's how it is able to find out the entire answer to this question. Then we have ILSA. ILSA is another payload attached in the lunar, landing probe, which is lunar seismic activity. Now, instrument for lunar seismic activity. Here we have simply taken a seismometer and we have deployed the seismometer onto the surface of onto the surface of moon. Now, a seismometer or a seismograph will only be able to find out what is the internal structure of the moon made up of. So far, we have only speculated that the internal structure of moon may contain a core like planet Earth and such, but we have no idea how exactly the internal surface of the moon is structured. Does it also get earthquakes just like planet Earth gets? Does it also have tectonic plates? And if there are tectonic plates, then how these tectonic plates have been moving, right? All possibilities of answering anything based on the internal structure of moon, we can easily identify with the help of ILSA, right? It is another payload that has been deployed on our lunar module, now on our lander module. Now the lander module, because it has been deployed at a specific location, the lander module will have a working life. The overall working life of this module is expected to be around 14 Earth days, close to 14 Earth days. Why 14 Earth days? Remember, when you look at the moon, moon does not have the same rotational speed as that of planet Earth. It takes around 27 and a half Earth days to complete entire rotation of moon. So if the moon is spinning, it will take around 27 and a half Earth days, 27 and a half Earth days for completing one entire day and night of the lunar day. One entire day and night, 27 and a half Earth days. So which comes out to be approximately 14 days of day, 14 Earth days of daytime, and 14 Earth days of night, right? So what happens when the moon starts spinning? For the 14 Earth day equivalent of time, there would be sunlight reaching one side of the moon, right? There would be sunlight reaching one side of the moon. And when the moon shifts after 14 days, the same area where there was sunlight reaching, that will become the night part. It will get exposed to darkness, and not just darkness, even the fall in temperature would be somewhere around minus 180 degrees. So that is going to be the temperature at the other end of the moon. So you guys can understand the objective of the mission objective, or the mission duration of the landing probe, or the lander of Chandrayaan-3. It is 14 Earth days. That means it will function till the time there is sunlight received at the landing probe. I hope you guys are able to understand. So this is basically are the three important scientific payloads that we have deployed at the landing module. Now the next one is rover. Now the rover of Chandrayaan-3, it is still having the same kind of payload that was supposed to be there in the rover of Chandrayaan-2. The rover of Chandrayaan-3 contains mostly two types of payloads, and because you understand that Chandrayaan-3 rover is supposed to travel onto the moon surface, so as it is traveling onto the moon surface, its objective is very clear, that it is supposed to study the moon, lunar mineralogy, lunar topography, and such things, right? By the way, the life of Chandrayaan-3 rover is also equivalent to 14 Earth days for the same purpose, for the same reason, because even this is also powered with a solar cell, and the solar cell will be functional for the 14 Earth days only, right? So it is basically going to have alpha particle X-ray spectrometer. It is having an objective of knowing the chemical composition and the mineralogical composition of the lunar surface. Then there is LIBS, laser induced breakdown spectroscopy, and which is basically going to derive the elemental composition and find out the presence of elements like magnesium, aluminum, silicon, potassium, calcium, titanium, iron. These are the important elements that are often considered to be abundantly present onto the lunar surface. So if we are able to discover these elements there may be a possibility in future we may think of using these elements for some constructive applications. We'll talk about those applications later, right? So they are known as LIBS, laser induced breakdown spectroscopy. By the way, I hope you guys remember that India is also one of those countries where Chandrayaan-1 became the first probe ever to find the evidence of water onto the lunar south pole, right? So basically Chandrayaan-1 discovered the hydroxyl group present on the lunar surface, and also the presence of water ice. Now with this particular achievement, it has already been confirmed that there is a possibility of hydroxides or OH group and water present. Along with that, if we are able to find these other elements also, the understanding of lunar mineralogy will definitely expand for the rest of the world as well. Now let's talk about how exactly the journey of Chandrayaan-3 took place. Now this is going to be a detailed discussion of the entire journey. I'll try to explain the entire journey in a very simple way so that even a layman is able to understand this concept. Now this is the basic outlay of the entire trajectory. As you can see that here we can see this is the planet Earth, right? And from planet Earth it is moving into the lunar transfer trajectory and then eventually enters into into the lunar orbit. Now, when you try to look at this entire concept, the understanding of this concept is very simple, guys. But to understand the concept easily, we have to understand a little bit of gravity, how the gravity behaves, and this is something that all of you can easily experience. So, if I may, let's see this part. Suppose if this is planet Earth, guys. Suppose this is planet Earth. It's very obvious that the force of gravity is always acting towards the center of the Earth. I hope this is something everybody knows, that the force of gravity is always going to be functioning towards the center of the Earth, right? Now, it's very obvious that if you take an object and you try to throw this object away from the Earth's gravity, it's very obvious that the object will eventually, if you try to throw it away from the Earth's gravity, what will happen? The object will start slowing down, because the Earth's gravity is always going to be pulling it, and the object will slow down, stop, and then starts falling back. Even if you throw it with a slightly higher effort, it may go up to a slightly higher altitude, but then from there also it will start falling back. So technically, any object that goes away from the Earth's gravity, it will obviously slow down and eventually stop and start falling back. This kind of motion, where the speed decreases with time as it slows down, we call this motion as a retardation motion. We call this motion as retardation or deceleration, deacceleration, you can call it. Similarly, if suppose there is an object, that travels in the direction of Earth's gravity, when you drop an object in the direction of Earth's gravity, the object starts traveling in the direction of Earth's gravity, and as it travels further, you will notice that the object starts getting accelerated. We also have a concept of small g, guys, that is called acceleration due to gravity. It is an acceleration that is achieved in the direction when an object travels in the direction of gravity, right? Now, whenever an object travels in the direction of gravity, its speed is going to increase, its velocity will eventually increase, and we call this kind of motion as accelerated motion. Now, this is something that is very common or very easily understood by almost all the students, because this is something that we experience in our day-to-day life. When you throw an object away, it slows down, starts falling back, and when you drop an object in the direction of gravity, it speeds up. So this is nothing but the retardation caused due to gravity and acceleration caused due to gravity. Simple. All of you guys are able to understand. Now, let's try to put this logic into the launching of the Chandrayaan-3. Now, see, let's try to understand this with a perspective. Let's say if this is planet Earth and this is our moon. This is our moon, right? And we want to send a probe from Earth to moon, guys. We want to send a probe from Earth to moon. Now, one way of doing this is that we burn a lot of fuel, we give a lot of force to our rockets, and then we put a huge amount of energy so that the probe directly goes out of the Earth and reaches the moon surface. But in this way, we will have to burn a lot of fuel, guys, because in order to escape out, in order to move out from the Earth's gravity, the fuel consumption will be way greater. Countries like USA, Russia, they have built rockets already which are capable of achieving a speed high enough that they can propel themselves completely out of the Earth's gravity and enter into any other planets or any other gravity of other objects. Now, India have also built rockets, like our GSLV is capable of escaping out from the Earth's gravity. It is capable, but it will not be a wise decision to burn a lot of fuel in the first stage itself and then wait for the rest of the fuel to carry the entire probe to moon and then reach there. In order to reduce the reduce the cost of the mission and also reduce the fuel consumption here, improve the fuel efficiency, we can obviously take help from gravity here. We call this kind of propulsion as gravity assisted propulsion. And how this gravity assisted propulsion works, it works in a simple principle of acceleration and deacceleration due to gravity. Just keep a note of it, guys. So let's say, for example, we have got planet Earth here and we want to propel an object out of the Earth's gravity. We have to give a very high speed to this object out of the Earth's gravity. So what we know here, we normally do not put an object directly out of the Earth's gravity. Like, it's not like if you want to put this, if you want to put Chandrayaan-3, for example, to moon, it's not like ISRO is not going to put it directly out of the Earth's gravity. What ISRO does here, the mission controller at Bangalore, what they do here, they first put the probe around Earth in an elliptical orbit, guys. elliptical orbit is one which is not a circle. I hope you understand what is an ellipse. Ellipse is basically something which is not a circle, and if it is not a circle, that means it does not have a center of curvature. Rather, it has two focuses. It has two focuses, guys, and around the focus we have the minor and the major axis, and based on this we can draw an ellipse. You guys can understand the shape of an egg is, by and large, you can consider is close to an elliptical shape, right? So we normally put the space probe in an elliptical orbit like this. Now the closest point in an elliptical orbit, we call this as perigee. The closest point to the earth, we call it perigee, and the farthest point from the earth's surface, we call it apogee. We call this as apogee. Got it? So this is where we normally put the probe in order to save the fuel cost. So we are not putting it directly to moon, we are putting it in an elliptical orbit around earth. And now just use your common sense, guys. When you try to see, if you try to project the movement of this particular probe from apogee to perigee, or from perigee to apogee, so it is moving in this direction, moving perigee to apogee and then back to apogee to perigee. So you will notice, so you will notice that when an object is traveling from perigee to apogee, it is moving away from earth. It is moving away from earth in this trajectory, in this half of the journey. And when an object is traveling from apogee to perigee, it is moving towards earth. Right? It is moving towards earth, guys. So it's very obvious. In the previous slide only I showed you that when an object is traveling away from earth, it will naturally slow down, retardation. If an object is traveling towards earth, it will naturally accelerate, acceleration. So what happens when an object is placed in this elliptical orbit, when it is moving away from earth, its speed reduces and it slows down. And when it goes from apogee to perigee, its speed naturally increases because it is traveling towards earth, and it accelerates, right? It accelerates. Now this is a natural change in the velocity that happens due to earth's gravity when an object is traveling in an elliptical motion. I believe all of you guys have been able to understand. Now what ISRO did here, they basically deployed this particular Chandrayaan not in the orbit directly out of the earth's gravity. What they did, rather, they first took the Chandrayaan and they made it, or they deployed it at an elliptical orbit. The elliptical orbit kept the perigee somewhere close to just approximately 170 kilometers, approximately I'm saying 170 kilometers from the earth's surface, and the apogee kept on shifting. We call this mechanism as orbit raising maneuver. Don't worry about it, right? I'll explain all these things. So what they did here, they first deployed the Chandrayaan in an elliptical orbit, and then from the elliptical orbit they deployed this Chandrayaan from perigee to apogee. Now as it goes through from perigee to apogee, it will slow down, and then from apogee to perigee it will accelerate. Now as the Chandrayaan started accelerating, reaching perigee, the mission controller at Bangalore, when it reached the perigee, when the Chandrayaan reached the perigee for the first time, what they did, I'll draw it here, so that all of you are able to understand. So firstly they deployed it in an elliptical orbit, right, keeping the perigee at a distance of 173 kilometers, right? Previously I said 173 was the actual perigee. Now when Chandrayaan completed its first orbit, and came to the perigee for the first time, the mission controller at Bangalore, they gave a slight push to the Chandrayaan by turning on the motor and turning it off. So they turn on the engine and they turn it off, and by doing this they gave a slight push to the Chandrayaan. And once they give a slight push to the Chandrayaan here, we notice that the apogee of the Chandrayaan for the next orbit, it automatically gets raised, and then it starts falling. So once it reaches to a new apogee here, now the Chandrayaan will start falling from a higher apogee towards the perigee. And now once the Chandrayaan reaches the perigee for the second time, again the mission control at Bangalore, they gave again a slight push, and this time it is going to go into a higher apogee. So by giving these small pushes, the apogee of the Chandrayaan kept on raising, and they made sure that the perigee does not change. The perigee remains almost fixed. I'm saying almost fixed. That means it's not like it was fixed all the time, but almost it was kept near to 200 kilometers. It never increased from there. And that's how, by giving them a higher apogee, what happened? The distance covered by the Chandrayaan traveling from a higher apogee will increase, and as it is traveling in the direction of Earth's gravity, it will keep getting accelerated until it reaches a sufficient speed so that it can now escape comfortably out of the Earth's gravity. So when you look at this image, guys, you will notice that how the orbit, the apogee in every subsequent orbit is being raised. You guys can see. So it was done for the period of 5 times. So 5 times the orbit of Chandrayaan-3 was raised, and once after raising it to a 5th time, it reached to a certain altitude, that from there, when it started falling back into the Earth, it achieved a speed high enough that now even the Earth's gravity cannot keep it within itself. You only have to give a direction and then it will leave. So that's when we gave one more push. So for 5 times we kept on raising the orbit. We call this thing as orbit raising maneuver. Orbit raising maneuver. And this orbit raising maneuver was performed around the planet Earth for 5 consecutive times. And once the Chandrayaan reached the perigee, this would be the 6th time, guys, the mission controller at Bangalore, they gave one more push. But this time the push was given so that Chandrayaan would leave Earth forever. And this push was given on 1st of August 2023, and then Chandrayaan started its trajectory towards the lunar orbit. I hope you guys can understand. And you know what? The speed was significant enough that from here Chandrayaan took just 5 days. On 5th of June, also on 5th of August, on 5th of August 2023, Chandrayaan successfully reached its desired orbit of the lunar surface. But you know what? Its speed was very high. So on 5th of August, Chandrayaan made it to the lunar orbit. It reached the desired orbit of the moon. Did not land on moon. It simply reached to the orbit of the moon on 5th of August, right? And from here, once it has reached the desired orbit, what Chandrayaan did now, here, once it reached the moon, the mission controller at Bangalore, they fired the motor one more time. But this time they had to fire it in the opposite direction. See, as the Chandrayaan has left Earth, its speed is extremely high, guys. It has a very high speed when it is traveling from Earth to the moon. Now, once it reaches the moon, its speed is already very high. It is still very high. So what we have to do here, we have to now apply brakes. So the mission controller at Bangalore, once the Chandrayaan reaches close to the moon, the mission controller at Bangalore, they had to fire the motor one more time, but this time in the opposite direction. Because when you fire it in the opposite direction, it starts slowing down and eventually it slows down to a comfortable speed so that moon's gravity will start attracting it. Now moon's gravity will start attracting. So this will be known as the point of orbit insertion. This will be the point of orbit insertion where the Chandrayaan comfortably inserts into the orbit of the moon. I hope you guys are able to visualize this part. So once it travels and reaches the orbit of the moon, now the mission controller has applied the brakes and the mission or the Chandrayaan probe has now slowed down and eventually now it will enter into the moon's gravity. But see, the speed of Chandrayaan is still very high. It's not like it will enter into the gravity of the moon and will eventually start, falling into the moon's surface. It cannot happen straight away. So we have to very slowly, very calculatively, we have to start reducing its orbit. So we call this phenomena as orbit reduction maneuver. Orbit reduction maneuver, right? Reduction maneuver. So what we did here, we first made the Chandrayaan, because see, its own speed is very high. Chandrayaan's own speed is quite high still, even though we have applied brakes, but it is still having a very high speed. So we have to slow down the Chandrayaan so that the Chandrayaan uses less fuel, and using the gravity of the moon itself, we can direct the Chandrayaan back into the moon's gravity. So what we have done, we have applied some brakes here, and the Chandrayaan has got slower, and now its own inertia, it has got entangled with the moon's gravity, and now it will start revolving. So first it will revolve because of a high speed. It will take a high ellipse, and then once it reaches the perigee, we'll again put a slight brake. Then it will take a smaller orbit. then it again reaches the perigee, again we'll apply a small brakes, then it takes even smaller apogee. Likewise, it is exactly the reverse that we did, guys. In the previous topic where we were moving out of the Earth's gravity, we have to raise the apogee. Here we have to reduce the apogee so that slowly and slowly it starts moving, and as it starts moving slowly and slowly, we'll keep reducing the apogee, further, keep reducing it further, and until it enters into a very slow speed into the moon's orbit. I hope you guys can understand this. And you know what, when this is eventually achieved, we notice that after we keep reducing the orbit of the Chandrayaan, we reach a time when the orbit of the Chandrayaan becomes nearly circular. The orbit of the Chandrayaan becomes nearly circular. You can see that previously it was an elliptical orbit, but as we have applied brakes strategically, its orbit have become nearly circular to a 100 by 100 kilometer orbit. So now the Chandrayaan is just 100 kilometers away from the moon's surface, and at this point, when it is just 100 kilometers away from the moon's surface, the propulsion module, guys, the propulsion module that was propelling the Chandrayaan so far, giving it the right direction, it has now detached. The propulsion module has got detached when it is just 100 kilometers above the moon surface. The propulsion module has got detached, and now the lander is separate and the propulsion module is separate. Remember, the propulsion module also has a payload, guys. It also has a payload. If you remember, the payload was called SHAPE, to study the signatures that Earth propels out in the space, to know if there are other planets also that can be habitable. So this particular payload will still be attached with the propulsion module. So here you can see the image, guys. Here you can see the image. This is the point where the propulsion module separates. So once the propulsion module separates, the propulsion module will still keep revolving around the moon at an altitude of 100 kilometers, and the life of the propulsion module is around 3 to 6 months. For 3 to 6 months of time, the propulsion module will keep revolving around the moon. It is not going to go away anywhere. For 3 to 6 months, that will keep functioning, and now the lander will take its own course, slowly and slowly moving towards the moon's gravity. So you can see that on 23rd of August 2023, from the 100 kilometers altitude, the lander deboosting started when it was brought to a distance of just 30 kilometers away from the lunar surface. So from 30 kilometers away from the lunar surface, the deboosting phase started, and then the lunar lander, when it was just around 25 to 134 kilometers, as you can see, it left its natural trajectory and eventually started diverting, started falling towards the moon surface. Now here it was of course having a high vertical velocity. Vertical velocity was also there, and it was also having a high horizontal velocity, right? So the mission controller at Bangalore, they had to maintain that as the lander enters or starts falling into the moon's gravity, it should have the right horizontal and vertical velocity. And once it got the right horizontal and vertical velocity required for lander to work, its automatic landing equipments were turned on, and then the rest of the journey was completely done autonomously. Mind my words, guys, India did not just demonstrate a successful soft landing, but this soft landing was done through complete automation. It is an important achievement for India's automation AI based technology as well. Mind my words, guys, right? So it is a good demonstration of India's capabilities of defining self-regulated automatic systems as well. So this entire horizontal and vertical velocity, once it reached to the desired levels, from here it started descending, and as it started descending, the automatic landing system, it got activated, and slowly the Chandrayaan landed, right? So where exactly the Chandrayaan was landed? So you guys know, we call it the south pole of the moon, but in technical terms it is called the Atkin Basin, guys. It's called the Atkin Basin. Atkin Basin is basically the location where, you know, the south pole of the moon is located. It's called Atkin Basin, right? Now this Atkin Basin is basically a place which is related to or comes somewhere close to the Atkin crater, and the mission control of Chandrayaan-3, they identified an area of 2.5 kilometers to 4 kilometers. 2.5 kilometers to 4 kilometers of area they identified, and they considered this particular area as the point of landing. Now Chandrayaan-3, because of the flawlessly functioning of the ALS, the automatic landing system, it landed on the desired carpet that was kept onto the South Pole. If you want to know where is the current location, the location of this Atkin Basin where we landed, it is somewhere around 350 kilometers away from the actual South Pole. So it is not exactly at the point of the South Pole, but it is in the nearby region around 350 kilometers away from the actual South Pole where we have been able to land. I hope you guys can understand this. So this is where the landing position, landing of Chandrayaan-3 happened. Now you guys know that Chandrayaan-3 was based on a very unique failure-based design, right? Because here anything that could go wrong was already taken into perspective, was already taken into consideration. And we also studied what were the reasons that made Chandrayaan-2 fail. So Chandrayaan-2 got failed. There were multiple reasons for it. Firstly, the target area that was kept for Chandrayaan-2, it was just 500 meters by 500 meters. 500 meters by 500 meters. This was the target area. So you can understand when you have a smaller target area, it's difficult to aim, right? For Chandrayaan-3, it has been increased to 2 by 5 to 4 kilometers. So the area has got bigger. So the software will not have any glitches. It will not be able to have any problems in identifying the actual patch where they have to land. Secondly, Chandrayaan-2, guys, it was basically the lander of Chandrayaan-2 had total 5 engines. Now you can understand keeping odd number of engines is very difficult to manage, especially when the entire system is going to go automatically. So this software glitch that happened in Chandrayaan-2 was basically one of the reason was the high instability of engines that were created, because when we are putting 5 engines, it becomes very difficult to manage the entire stability of the module. So because of any small misfire of any engine will happen, the entire stability of the module is lost and the mission would fail. In Chandrayaan-2 on the other hand, in Chandrayaan-3 on the other hand, we have basically put 5, in Chandrayaan, I'm sorry guys, Chandrayaan-3 on the other hand, we have basically put 4 engines, guys. You can see 3 of them, here we basically installed 4 engines, and by putting 4 engines, we can actually provide better stability to the Chandrayaan-3 compared to the Chandrayaan-2, which primarily had 5 engines, guys. And that's why it had more jerks, more issues related to stability, and of course, as it failed, so one of the reasons for the failure was the instability of the entire module. Now, so this is basically how the journey took place, and this failure-based model has worked flawlessly for ISRO, and with this entire functioning and this entire trajectory of the journey of ISRO, Chandrayaan-3 took a successful touchdown on 23rd of August 2023. Now, once as we have studied how the landing and how the journey of Chandrayaan-3 took place, let us now try to understand what is the significance of this achievement for India. Now see, moon is full of opportunities, guys, but before I talk about what moon can really, what advantage we have for India's successful landing on moon, I want to talk about how stronger achievement or how big achievement it is for India as a country. See, we all understand that the future of technology, we often use the word artificial intelligence, right? We talk about machine to machine communication, we talk about Internet of Things, we talk about a lot of innovations around us, guys, faster communication technologies. All these things, they pave way for the future of technology, right? Now, with the successful landing of Chandrayaan-3, just imagine how many opportunities it will open up for India's AI market, for India's presentation of, or India's position in the future hub of artificial intelligence. It has demonstrated the world that how strong the Indian mindset and the Indian technologies could be in performing a successful task of landing on such a position where no country has ever tried, or no country whoever have tried has failed. You guys know very recently Russia has failed. Before this, Japan and Israel, they both have failed. They both were also trying to reach the South Pole, but even they have failed. So it is the first time a country has landed onto the South Pole, and that too by demonstrating a complete autonomous landing system which has worked successfully without fail. So it will not only give a very strong impulse to or a very strong impetus to the Indian technological know-hows, but in the entire world also, world over as well, it will definitely raise India's position as a next hub of AI or automated technologies country. Now let's try to look at how this particular achievement of India can work out for us in future. So what is the big one, what is this one advantage that we have on lunar mission is that when you land onto the moon, you can definitely learn a lot about our Earth and the solar system's early history. You know why? Because there are a lot of locations on moon, especially the south pole of moon. It is believed to be completely untouched for the last billions of years. I'm saying, guys, billions of years. The lunar surface has been completely untouched, unaffected. Only in the initial solar system, moon got hit by a lot of asteroids, lot of meteoroids, so they have created some craters, but otherwise the lunar surface is largely untouched, unaffected. So if you want to learn how the early history of the solar system and planet Earth carved out, moon can be a very good destination which can have the fingerprints of the old history of Earth, which has lost on Earth particularly, because we have so much of tectonic plate activity, so much of oceanography and tectonic events are happening on Earth, geomorphological events are happening on Earth, which changes the original state of the planet Earth when it was recently created. Okay, so asteroid impacts, if you want to study what is the role of asteroid impacts on creation of any landmass, moon can definitely help us to find answers. Then moon, as it is a very secluded, completely free from any life forms, it's a place where any kind of experiments can be performed and we don't have to worry about any ailments or any harmful effects of those experiments. So it becomes an excellent place for testing new technologies like flight capabilities. If you want to test, moon becomes a very good destination to do that. Life support system, if you want to check, if you want to develop exploration technologies for future, mining technologies for future, all these things are possibilities when it comes to moon, because moon is simply something which is completely secluded. Any experiments that you perform on moon, it will not hamper or not affect Earth. Then Chandrayaan-1, as I said already, it discovered water and hydroxyl group. So this is of course one important feather in the cap of ISRO that we have already discovered. We have already given this information to the world. Then we have also, in fact, NASA has also confirmed that there could be a presence of almost 100 million tons of rare earth elements. 100 million tons of rare earth elements may be found on the lunar surface, but so far we haven't been able to discover a possibility of mining those rare earth elements. But you know what, guys, this is actually one of the objectives of many space organizations. Possibly every space organization have this long-term objective of finding these minerals and then making these minerals to use or bringing them to use for developing some high-end cutting edge technologies of the future, because they essentially require rare earth elements there. So 100 million tons of rare earth element may be found on the moon surface. In fact, let me quote here that Chinese National Space Agency, CNSA, they have this as one of their objectives to find opportunities for space mining, where you can go and mine minerals from the space. And there is also, again, this goes to the Chinese National Space Agency, that they have also been able to find some traces of helium-3. Now helium-3 happens to be a very popular future nuclear fusion fuel. It can be a very popular fuel for nuclear fusion in future. When it comes to nuclear fusion, there are a lot of countries already working on Earth which are trying to find the possible techniques to demonstrate a successful nuclear fusion energy. Nuclear fusion energy is considered to be the future of clean, unlimited source of energy. But when you want to conduct these energy sources, when you want to practically perform these conduct experiments on these energy sources, we require a good supply of fuel. So moon, if in future ever moon is colonized, it has helium-3 which can effectively be used as a future fuel for nuclear fusion energy. So you can see that in terms of energy, moon has the availability of resource. In terms of manufacturing and mining, moon already has the presence of some rare earth elements, minerals. Then when it comes to water, Moon already has some availability of water. Acha, by the way, water can also be used as a fuel. Water is made up of what? Water is made up of hydrogen and oxygen. Hydrogen is a very good fuel, already proven. You guys know National Hydrogen Mission is going on, that is harnessing hydrogen based technology in the future. So hydrogen is of course a fuel. So there is a possibility of energy, minerals, water, all these things are already there on the moon. So we only have to take human settlements. It is possible to colonize moon, it is possible to build colonies on moon or develop a ground based space station on moon, which can eventually help in refueling, it can help in providing new kinds of fuel sources in future, and also support, develop life support systems and help us in development of the entire human race. Then the long-term objective of many space organizations is to conquer Mars, is to colonize Mars. But the wiser thing would be if we can develop technology to first set up a space station on moon, then that technology can obviously be replicated for even farther object like Mars. So first conquer moon and then go to Mars. And then lastly, India has recently become a member. India has recently become a member of the Artemis program. And Artemis program happens to be a civil, space collaboration deal between USA and various countries headed by USA itself. So there are a lot of countries which have become a part of Artemis program. India is the latest one to join in. And if India officially becomes a part after the ratification by the parliament, then India will become a part of a group where USA have an objective of setting up or sending human astronauts in space after a time of 70 years, after a time of 50 years. And it will also be replicating, it will also be putting up a space station around the moon orbit. So India can definitely learn a lot of, we can get a lot of data, and we can obviously learn a lot more things in the area of space, in the area of overall space technology. Now, then moving on to the last section of our discussion here is, what are the other countries which are working in the area of space, in the area of on lunar exploration. So although there are many countries which have sent their probes, like I already mentioned, European Space Agency have also launched one of their probe called SMART, but it is a single probe that is working of European Space Agency. Eventually it was crashed into the lunar surface, so right now they don't have any working project as in for now. Then Japan has already tried and failed, Israel already tried and failed. So many countries have tried. So I'm not basically taking a list of all the countries here. I'm particularly talking about those countries which are somewhat significant players in the area of space commerce, and those missions which are already actively working. So first, let us see China. China has been exploring a lot in on the moon. They have a project called Chang'e project. The Chang'e project has already successfully launched 5 probes. They have already successfully implemented 5 projects under the Chang'e probe. The Chang'e 1 was launched in the year 2007 and followed by Chang'e 2, then Chang'e 3. Chang'e 3 became the first probe to actually land a rover, like what we have achieved, in Chandrayaan-3. China was able to demonstrate in 2013, but remember, we have done it at the South Pole. No country has reached there so far. Then Chang'e 4 became the first probe ever to reach the dark side, or you can say the far side of moon. It became the first probe ever to reach the dark side or the far side. Actually, what happens, guys, when you're looking at the moon, we can't see the entire face of moon. Actually, we see only one side of moon always. On Earth, we can only see one side of moon. We can't see the other side of moon at all. So we call the other side of moon as dark side or far side of moon. China became the first country to successfully land and also make a rover move on the dark side of moon, Chang'e 4. And Chang'e 4 also had some major important scientific innovations. Like Chang'e 4 also took some terrariums. They also took some concealed bottles of seeds which were deployed on the dark side of moon, and it was found that the plant seeds were able to successfully germinate, although it was put in an encapsulated environment, but it was glass made, so they were able to germinate on the moon, on the lunar surface comfortably till the time the sun's radiation were reaching to the moon surface. But like you guys know, after 13 to 14 days, when the night comes, the temperature of the moon surface falls to minus 180 degrees Celsius, and during that time the temperature falls to such an extent that now all those plants that germinated successfully in Chang'e 4, they died after the 13-14 days. But then China launched Chang'e 5, guys, and Chang'e 5 became a sample retrieval mission. So they retrieved a sample of Changi 4, these plant samples, and also took some sample of moon soil, moon rock and all these things, and they brought those samples back. So China has not only landed on moon, but with Changi 5 they have also demonstrated a capability of taking the sample of moon and bringing it back to earth. Mind my words, this has already been demonstrated previously by NASA, right? So they have brought samples back. You guys know that the human missions of NASA have already, been executed, and they have been successfully able to bring samples. So China has also demonstrated by bringing a sample of lunar surface from the dark side under Changi 5. Now China is planning Changi 6 by 2025. It was earlier being planned for 2024, but they have been delayed. And then later on, China also have a plan of sending 2 more probes, Changi 7 and Changi 8, and they will also be expanding their horizon of understanding. By the way, Changi 6 will be China's first attempt to reach the South Pole. So China would put Changi 6 probe to reach the South Pole. It would be Chinese first attempt to reach the South Pole, right? Then now let's talk about the American NASA. Now NASA has a program called Artemis program, and India, as I said in the previous slide, has recently joined it. Under the Artemis program, there are total 5 probes that has been scheduled, and Artemis program is basically, the objective is to put humans again back on the moon surface. See, the last time when the Americans sent humans was way back in 1972, and it has already been 50 years now that no humans have walked onto the moon surface. So in 1972 they last sent, and now under the Artemis program, Artemis 1 has already been successfully launched. It was a probe that was simply went around moon and came back. It was an unmanned mission, but they took some robotic and some mannequins to just replicate how the actual human journey would take place. Then Artemis 2, which is expected to be launched in 2024, will send astronauts to moon, but they will not be landing. They will simply be taking rounds of the moon and come back, right? And they will be studying how their body responds to this. Artemis 3, on the other hand, is going to be a landing mission where astronauts will go and successfully land onto the lunar surface and walk onto the lunar surface. By the way, remember this, that under the Artemis program, NASA is already having an objective of putting a woman astronaut on the moon surface. So Artemis has already considered some women astronauts. They will be walking onto the moon surface, right? In 2025 it is expected. Then in Artemis 4 2028, NASA will be putting up a gateway station. They will be putting a small gateway station, a temporary inhabited station around the moon orbit, and they will be putting astronauts. They will be docking next to the gateway. They will be parking the entire spacecraft next to the gateway station, and then they will be transferring astronauts from the spacecraft into the gateway station, and those astronauts will be staying there. Around 4 astronauts they will be sending. Then Artemis 5 is also going to be the third manned a lunar project of USA that will be launched in 2029, and they'll be sending again human crew members to the lunar surface. Then comes Russia, guys. Russia's space organization is called Roscosmos, and they already have a lunar program, but you guys know recently the Lunar 25 probe has failed. So technically Luna, or the work of Russia in moon exploration, has not been very significant since a very long time. And this lunar probe was also the Russian attempt of reaching moon after a gap of almost 50 years. And unfortunately, this has failed. The Lunar 25 probe has failed. Although Russia already has a joint venture with China. They have already signed a joint venture with China. It is called ILRS. It's called Interlunar Research Station. So Russia has already signed an agreement with China. It is considered against the Artemis program that Russia and China together may try to set up a research station based on the lunar surface. So by 2035, even though Russia may not be having any actively working mission on moon, but by 2035 China and Russia together against the Artemis program may set up an international lunar research station, right, which will be expected to be set up by 2035. So guys, these are the major missions that have been going on. Like I said, other countries are also trying to reach. In fact, I forgot to mention UAE. It became the first Arab country to reach moon, but unfortunately their mission also failed. So they haven't been able to reach here. And India, as you guys know, has become the 4th country to successfully touch the moon surface and the 1st country to successfully reach the South Pole. So I hope guys this entire discussion has been helpful to you guys. Please give me a comment so that I can learn more about how to improve the content and everything else that we have been delivering here. Thank you guys. All the best.